Anthony Raj. He has pursued his bachelor's, master's and MPhil in physics. He then went on to pursue his PhD in physics at the University of Madras as well. He then went on to work as a lecturer at Tiruvalluvar Arts and Science College and Idea Engineering College for Women. Since the year 2006, he works as the lecturer and assistant professor at Loyola College, Chennai. With regard to research, he has published several papers in international journals, namely Radio Wave Propagation over Salem, Linear and Non-Linear Optical Properties of Pure and Doped Selenium Malate Single Crystals, and many more. He has also attended several conferences and seminars, namely International Conference on Materials Science and Technology, National Conference on Higher Education at Crossroads held at Loyola College, National Seminar on Crystal Growth 12 held at VIT University, and many more.
Welcome to UGC lecture series B.Arc Semester 1 Mathematics Lecture 4. In this lecture, we are going to discuss three-dimensional analytical geometry. In that three-dimensional analytical geometry, direction, cosine and ratios of a line, then angle between two lines. These two concepts we are going to discuss in this lecture. Directional cosines. To understand the concept of direction cosines, we need to understand some important terms in the analytical geometry. Skew lines. The first term is skew lines. Two non-intersecting lines are called skew lines. Those two non-intersecting lines are non-coplanar lines. So, such lines are called as skew lines. Example for the skew lines are any two opposite edges of a tetragon are skew lines. Then angle between two lines. You know, skew lines and angle between two lines are basic definitions to be learnt to understand the concept of directional cosines. Angle between two lines. If the lines are coplanar, that is intersecting, then the acute angle between them gives the angle between the lines. So, if two lines are there, that two lines are coplanar and the two lines are intersecting, then the acute angle between them gives the angle between the lines. If the lines are skew, you know, the definition of skew line says that two non-intersecting lines, that is non-coplanar lines, are called as skew lines. So, if the lines are skew, then the angle between two lines drawn parallel to the given lines through an arbitrarily chosen point in the space gives the angle between the lines. So, to get the angle between non-intersecting lines, we need to choose an arbitrary point in the space and we need to draw two lines parallel to that skew lines through that arbitrarily chosen point. Then the angle between the lines will be obtained. Using these two concepts, we can go to the direction cosines of a line. You know, if a line makes angles alpha, beta, gamma with the positive directions of the x, y and z axis respectively, then cos alpha, cos beta and cos gamma are called the direction cosines of the given line, and the angles alpha, beta, gamma are called direction angles of the given line. So, from this definition, we learnt that direction cosine gives the cos of the angle made by the line with the x axis, then cos of the angle made by the line with the y axis, and cos of the angle made by the line with z axis. So, these three are called direction cosines of a line, and the angles alpha, beta, gamma, that is angle made by the line with the x axis, angle made by the line with y axis angle made by the line with z axis are called direction angles of the given line. Now, direction cosines of a line are generally denoted by L, M, N and written as square bracket of L, M, N. So, direction cosines are written or denoted by using a square bracket. L, M, N are the common denotation letter used to represent the direction cosines of a line, where L is equal to cos alpha and M is equal to cos beta, N is equal to cos gamma. This is how direction cosines of a line can be defined. Next, find the direction cosines of the coordinate axis. By this example, we will learn how to find or how to calculate the direction cosines of a line. In this example, we are asked to calculate the direction cosines of the coordinate axis itself. So, we will understand how to calculate the direction cosines of the given line. Solution to this problem will be like this. Here in this problem, it is said that the coordinate axis, what is the direction cosine of the coordinate axis? So, let us take the x axis first. This x axis makes an angle 0 degree with the x axis itself, with the x axis itself. Then the x axis makes an angle 90 degree with the y axis. Then this x axis again makes an angle 90 degree with the z axis. So, direction cosine of the x axis will be cos 0 degree comma cos 90 degree comma cos 90 degree. So, this is given in square bracket. So, we got cos 0 is 1, then cos 90 is 0, then cos 90 is 0. So, the direction cosines of the x axis is direction cosine of x axis is this one. Then direction cosine of y axis. You know, y axis makes an angle 90 degree with x axis, or y axis is at 90 degree angle from the x axis, then y axis makes an angle 0 degree with itself. Then the same y axis makes an angle 90 degree with z axis, or y axis is at 90 degree from z axis. So, the directional cosine of y axis is cos 90 degree comma cos 0 degree comma cos 90 degree. So, these three are the direction cosines of y axis. You know, cos 90 degree is equal to 0, then cos 0 degree is equal to 1, again cos 90 degree is equal to 0. So, the direction cosines of y axis is this one, cosines of y axis. Then direction cosines of z axis. You know, this z axis is at 90 degree with x axis, then at 90 degree with y axis, then at 0 degree with z axis. Z axis is at 0 degree with itself. So, the direction cosine of z axis will be cos 90 degree comma cos 90 degree comma cos 0 degree. The value of cos 90 degree is 0, 0, 1. So, this is the direction cosine of z axis. Now, the directional cosine of all the coordinate axes are 1, 0, 0. This is the direction cosine of x axis. Then direction cosine of y axis is 0, 1, 0. This is y axis. Then direction cosine of z axis is 0, 0, 1. This is z axis. This is how you can calculate the direction cosine of the axis. So, this is how you can apply the concept of directional cosines to a line. Next, we will move to the concept like relation between directional cosines. You know, directional cosines are cos alpha, cos beta, cos gamma. Relation between these direction cosine is this one, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is the relation between directional cosines. Now, let us see how to prove this relation between directional cosine. To get the proof of this relation, we need to imagine a coordinate system. This is the coordinate system. In this coordinate system, this is assumed as x axis and this is assumed as y axis and this is assumed as z axis. Then the line to which the directional cosine is to be find is this line. This is A, B. According to the concept of finding directional cosine of a line, we need to draw a line from the origin parallel to the given line. So, this is the line from the origin. This line, end of that line is named as C, and this line makes an angle alpha with the x axis, and this line makes an angle beta with the y axis. So, this is angle beta, and this line makes an angle gamma with the z axis. So, cos alpha, cos beta, cos gamma, these three are the direction cosines of the given line. Next, so directional cosines of this line is cos alpha, cos beta, cos gamma. These are the three directional cosines. Now, let us imagine a point P on the line OC. So, the point P is here. Then coordinates of this point P is x1, y1, z1. These three are the coordinates of the point P, and the distance of the point P from the origin is assumed as r. So, this is the distance of the point from the origin. Now, draw perpendicular PM and MN from P. So, PM and MN from P and M from P and M to the xy plane. So, this is the perpendicular. Then from the triangle O and P, draw a perpendicular PM to the plane xy plane. To get the relationship between direction cosines, we need to draw a line parallel to the line for which directional cosine is to be obtained. Now, the parallel line is OC. Then imagine a point P in that parallel line. Draw a perpendicular MN which meets at the xy plane. Then these are all the angles in that line. Now directional cosine of that line can be obtained like cos alpha is equal to x1 by r. This directional cosine is obtained from the triangle ONP. Similarly, we can get the directional cosine cos beta as y1 by r, then cos gamma as z1 by r. These three directional cosines were obtained from the triangle ONP. Now, to get the relationship among the directional cosine, let us square all the three directional cosine and add. So, squaring cos alpha, which will give cos square alpha is equal to x1 square by r square, then cos square beta is equal to y1 square by r square, then cos square gamma, which is equal to z1 square by r square. Now, add all the three squared directional cosines, you will get cos square alpha plus cos square beta plus cos square gamma. So, cos square alpha is x1 square by r square, then cos square beta is y1 square by r square, then cos square gamma is z1 square by r square. So, summing all the three terms will give this r square is a common one. So, x1 square plus y1 square plus z1 square. You know, in vector calculus, the position vector of a point or a line in a coordinate system r square is equal to x1 square plus y1 square plus z1 square. This is how position vector or length of a line can be obtained. So, instead of this x1 square plus y1 square plus z1 square, you can substitute r square. So, this expression will become r square by r square, which is equal to 1. So, like this, relation between directional cosines can be proved. So, in this proof, what we learnt is we assumed a line parallel to the line, then we assumed a point in that line, then we took a triangle OPN. In the triangle, cos alpha is equal to x1 by r, then cos beta is equal to y1 by r, cos gamma is equal to z1 by r, then cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is how relation between direction cosines can be proved. Then an example. Find the direction cosines of a line that makes equal angles with the axis. In this example, you are asked to find the direction cosines of a line that makes equal angles with the axis. So, while learning the direction cosine, we learnt that alpha is the angle made by the line with the x-axis, beta is the angle made by the line with the y-axis, then gamma is the angle made by the line with the z-axis. But here in this problem, it is given that that line makes equal angles with the axis. That means sum square of sum of all the directional cosines will give some value in this problem. Let us learn that value by solving this problem. So, solution to this problem is obtained like this. Let the directional cosine of that line be square bracket of cos alpha, cos beta, comma cos gamma. Then the relation connecting the directional cosines will be cos square alpha plus cos square beta plus cos square gamma. This is the relation connecting the directional cosines. According to the problem, alpha is equal to beta is equal to gamma. So that's what it is given. The line makes equal angles with the axis. So alpha is equal to beta is equal to gamma. So in the relation between directional cosines, instead of beta gamma, you can substitute alpha itself. So that relation will become cos square alpha plus cos square alpha, again one more cos square alpha. So sum of all the three cos square alpha gives 3 cos square alpha. So according to the relation, this is equal to 1, then cos square alpha is equal to 1 by 3, then cos alpha is equal to plus or minus square root of 1 by 3, which is equal to plus or minus 1 by square root of 3. So this is the value of cos alpha, one of the directional cosine. So all the three directional cosine will be same, because the line makes equal angles with the coordinate axis. Directional cosine depends on the angle made by the line with the coordinate axis. So the directional cosine in this problem will be 1 by root 3 comma 1 by root 3 comma 1 by root 3. This is one directional cosine. The next one will be minus 1 by root 3 comma minus 1 by root 3 comma minus 1 by root 3. Here this directional cosine is obtained by taking the obtuse angle. So obtuse angle, the directional cosine of the required line will be this one. So from this problem, what you learnt is how to find the directional cosine if the line makes an equal angle with all the three coordinate axes. The next concept is direction ratios. So far you learnt the concept of direction cosines. So direction cosine is an angle made by the line, cos of the angle made by the line with the x, y and z axis. Here the direction ratios are mere numbers. So three numbers a, b and c respectively, then a, b and c are called direction ratios. In short form, these direction ratios are denoted as d dot rs. So if the direction cosines of a line are proportional to three numbers like a, b and c respectively, then that three numbers a, b and c are called direction ratios of the line. Thus, if the directional cosines are given in a square bracket as square bracket of L comma m comma n, and the actual directional ratios of the line are the same, or the line or the directional ratios are given by L by A is equal to m by B is equal to n by C. Here L, m, n are the directional cosines. This A, B, C are the numbers to which the directional cosine is proportional, which is equal to plus or minus square root of L square plus m square plus n square over square root of a square plus b square plus c square. So which is equal to plus or minus 1 by square root of a square plus b square plus c square. Here this 1 came because the sum of square of the directional cosines L square m square plus n square is equal to 1. So that this 1 has come. Therefore, L is equal to plus or minus a by square root of a square plus b square plus c square, etc. Hence, the directional cosine of a line whose directions are direction ratios a, b, c are plus or minus a by square root of sum of a square, comma plus or minus b by square root of sum of a square, comma plus or minus c by square root of sum of a square. So, this is the direction cosine of a line whose direction ratios are a, b, c. This is how direction ratios are related to direction cosines. You know, this a square plus b square plus c square is not equal to 1 at this stage. Therefore, from the definition of direction ratios of a point where the point P is x1, y1, z1. From the definition of direction ratio of a point P of x1, y1, z1, the point Q is x2, comma y2, comma z2. So, the direction ratios of the point are x2 minus x1, comma y2 minus y1, comma z2 minus z1. So, this is how the direction ratios can be obtained. So, from this discussion we learnt that direction ratio is a number proportional to the direction cosines. So, in this lecture we learnt the definition of skew lines. Skew lines are two parallel lines, then angle between two lines. Angle between two lines is the angle of intersection of the acute angle of intersection of the two lines. Then directional cosines and ratio of a line. Directional cosines are nothing but cosine of the angle made by the line with the three axes like x-axis, y-axis, z-axis. Then direction ratios are mere numbers which are proportional to the directional cosine. These are all the concepts we learnt from this lecture. At the end of this lecture, you can answer the following question. Define skew line. What is known as directional cosine of a line? Define direction ratios or direction number. These questions can be answered after listening to this lecture. Thank you.
Right.